So we begin today looking at the graph of a very basic rational function, which is f of x is equal to 1 over x. Now it doesn't look like a complicated function, but the graph of it is very interesting. And what we're going to do is we're going to start out by plotting some points to see if we can get a general idea as to what this function looks like. So what I'm going to do is I'm going to create 4 t-charts. And those 4 t-charts are going to help me figure out what the graph of this function, f of x equals 1 over x looks like. Now notice that we do have a domain restriction here in regards to the denominator, that our x value can never be 0. Keep that in mind because that's going to become important in a few minutes. So we're going to start off by substituting some values in for x, and then seeing if we can figure out some basic patterns for f of x or for y. So when we go to our function over here and we substitute in 1, when x is 1, for f of x I get 1 over 1, which is the same thing as saying 1. So one ordered pair that's on our graph is 1, 1. Now what I want to do is I want to see what happens as my x values get really big. So I'm going to substitute some more numbers in for x, and you're going to see they're going to get bigger and bigger. What happens when we put in 10? Well, then we get 1/10, which is the same thing as saying 0.1. So let's graph that ordered pair. So here's 10 on the x-axis and 0.1 on the y-axis, which is pretty close to 0. So I'm going to try to make it as close to 0 as I can, without having the chalk blend into the y number line. So let's continue substituting in some more points, and we're going to let our x values get pretty big pretty quickly. When x is 100, y is 1/100th, which is the same thing as saying 0.01. For now, this point's really difficult. These ordered pairs difficult to graph. So let's just let some of these values get bigger and bigger and see if we can figure out a trend. So as my x value is equal to 1,000, my y value is 1 over 1,000, which is equal to 0.001, tenths, hundredths, thousandths. As my x value is 10,000, our y value is 1 over 10,000, which is equal to 0.0001. And now you should start seeing a little bit of a trend, and we're going to talk about the notation we can use for this. Our x values are getting really, really big. So what we're going to say is our x values are approaching positive infinity. Let's see if we can find a trend for our y values here. So as our x values get really big or they approach positive infinity, our y values 1, 0.01, 0.1, 0.01, 0.001, 0.0001, our y values, I don't know if you can tell this, but they're approaching 0. And so this picture should make sense within the context of what the graph is going to look like. And this is what we're going to say. As our x values approach positive infinity, our y values are getting closer and closer to 0. But I hope you can notice that we're never actually going to hit 0. We're going to get super close to it, but we can never hit it. So what that means is on this side of the graph, our x values are getting really big. This is where the x values get really big. Our y values are going to get super duper close to 0, which means that this piece of the arm, or this arm of the function, is going to get really, really close to 0 here, especially as my x values get really big, but it's never going to hit it. So there's one arm of the graph. Now I'm going to take a look at some other pieces of this function too. And again, what we're going to do is we're going to substitute in some points. So in this case, we're letting our x values get big. Now I want my x values to get small. In fact, I want them to get close to 0. So what I'm going to do is start substituting some values in for x, because I want to see what's going to happen on this part of the graph. As my x values get super duper close to 0, what's this portion of the graph going to look like? Okay, so we started with 1. Let's move into 0. Let's try 1/2. So when my x value is 1/2 or 0.5, my f of x value is 1 divided by 1/2. That's the same thing as saying 1 divided by 1/2, and that's the same thing as saying 1 times 2, which is 2. So there's another ordered pair in my graph. When x is 1/2, which is right here, our y value is 2. Interesting. Let's try substituting in some more points to see if we can figure out what's happening over here. Well, instead of 1/2, let's get even closer to 0. Let's try 1/10. Well, when my x value is 1/10, we get 1 divided by 1/10, and that's the same thing as saying 1 divided by 1/10, which is the same thing as saying 1 times 10 over 1, or 10. So another ordered pair that's on my graph is going to be 1/10 and 10. So 1/10 is really close to 0 over here. Let's count out 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's 1/10 and 10, which is even closer to 0. And let's see if we can continue with this trend and choose a few other numbers here. When x is 100th, we get 1 divided by 100th, which is the same thing as saying 100. So 100th, comma 100 is another order pair that's on this graph. And let's continue with this trend. When x is 1,000, y is 1 divided by 1 over 1,000, which is the same thing as saying 1,000. So if we can kind of generalize what's going on over here, our x values are getting smaller and smaller and smaller. And in fact, our x values are getting closer to 0. If we picture these in decimal form, this is 0.5. This is 1/10 is 0.1. This is 0.01. This is 0.001. Excuse me. Yeah, 0.001. So our x values are getting smaller and smaller. In fact, they're approaching 0. Look what's happening to our y values. But we have 2, 10, 100, 1,000. So our y values are approaching infinity. They're getting really big, so they're approaching positive infinity. And this piece of the graph should represent that. So as our x values get closer and closer to 0, our y values are going to shoot up to positive infinity like this. Our x's are getting closer, right here is 0, our x's are getting closer and closer to 0, the y values are going to shoot up to positive infinity. But notice our x value can never equal 0 because we have that domain restriction. So we're never going to equal 0, but we're going to get pretty close. Okay, so we have one portion of what this graph f of x equals 1 over x looks like. Now let's see if we can figure out what this left-hand part of the graph is going to look like. So instead of substituting in positive values as we did over here, now I'm going to substitute in some negative values so we can see what's happening over here in my second quadrant and my third quadrant. So for our next t-chart, let's do the following. So we're going to let our x values get smaller and smaller and smaller. We're going to start off when x is negative 1. Well, when x is negative 1, f of x is 1 over negative 1, which is negative 1. So there's one ordered pair that's on this graph, which is negative 1, 1. Excuse me, negative 1, negative 1, which is right here. When x is negative 10, we get 1 over negative 10, which is the same thing as saying negative 1/10, or negative 0.1. So negative 10 and negative 0.1, which is, now we're dealing with negative y, so we're underneath 0, but we're pretty close to 0 anyway. Negative 100, we have 1 over negative 100, which is negative 0.01. You can see if you can find some trends here. We have negative 1,000, 1 over negative 1,000, which equals negative 0.001, etc. In the trend that's happening over here, x is negative 1, negative 10, negative 100, negative 1,000. So our x values are approaching negative infinity. As our x values approach negative infinity, the y values over here are approaching 0, but it's a different approach to 0 than we had over here. Here we say our x values are approaching the positive zeros, or zeros from the positive side, and here we say our x values are approaching 0 from the negative side. That's going to become more important in a few minutes, but not right now. So what this is telling us is the following. As our x values get smaller and smaller and smaller, which is over here, smaller and smaller, approaching negative infinity, our y values are going to go through these points, and they're going to get closer and closer to 0 from the negative side, which means, and again, it's never going to touch over here. We're getting close to 0, we're never actually going to hit it. That's giving us that next arm to the graph. Now to figure out what's going on over here, now I'm going to start substituting in some values for x that are getting close to 0, but 0 from the negative side. I'm coming from my negative x values over here. So if x is negative 1/2, f of x is the same thing as saying 1 divided by negative 1/2, which is negative 2. So let's graph that ordered pair. Here's negative 1/2, and here's negative 2. Trying a few more points on here. If, let's say, x is negative 1/10, 1 divided by negative 1/10 is negative 10. If x is negative 100th, 1 divided by negative 100 is the same thing as saying negative 100. And we'll do one more If x is negative 1,000, y is the same thing as saying 1 divided by negative 1,000, which is the same thing as saying negative 1,000. Okay, so let's talk about what's happening to our x values. Let's talk about what's happening to our y values. Well, our x values are getting really small. This is negative 0.5, this is negative 0.1, this is negative 0.01, this is negative 0.0001. So these guys are approaching 0. We're getting closer and closer to 0, but again, from the negative side, and we'll talk more about that in a few minutes. And our y values, well, what's happening to our y values here? We have negative 2, negative 10, negative 100, negative 1,000. Our y values are getting bigger and bigger towards the negative side, so our y values are approaching negative infinity. So what that means is as our x values, over here, as our x values get closer and closer to 0, and we're coming from the negative side, so we're coming from the left, our y values are going to approach negative infinity. So we're getting close to 0, y values are approaching negative infinity, means they're going to shoot on down like this. And this is a basic graph of the function f of x equals 1 over x. And there's a few things I'd like for you to notice here. The first thing I want you to notice is we have this notion of what we call a vertical asymptote. In regards to the vertical asymptote, it's a line that our graph, it's a vertical line that our graph will never cross over. And the vertical asymptotes are always represented by the domain restrictions.